All right, so we look at 10A, and most of these questions that can be solved in the method we have learned. And obviously we have learned more than one method, right? We learned two methods, and you probably have learned some other methods. And let's try a couple questions, okay? I want you guys to, so let's first pick one question, okay? Actually, I'm going to create a question. This question actually is a part of a question from quadratic 4A. Okay, so I'm basically kind of, make a question, borrowing the question. Okay, so I say solve for x. Okay, and the inequality is x squared plus 2x minus 3, and we want it to be larger than 0. Then of course we saw this question that was in quadratic 4. This question is really part of, it's a question quadratic 4. Can we solve this equation using the method in 10A by doing the signs? Well, that depends on if we can factor it, right? If we can factor it. Factoring is a topic that I'm not ready to dive into deep into it, because that's that's the elementary algebra stuff. We're trying to, just go as we, you mention it and do it as we go along, while covering these more challenging topics. Well, in fact, okay, if we recall quadratic 4, right? Quadratic 4. Q-U-A-D-R. Okay, if we recall quadratic 4, we didn't solve this equation by factoring, right? We solve, how did we solve this? Right? If you go back, right? But this one can also be solved by factoring, as a matter of fact. Okay, recall the methods in quadratic 4, right? We make a perfect square, and then we identify the x-intercept, y-intercepts, and so on and so forth. So to solve this inequality, okay, of course we had 4 inequalities in quadratic 4, and the 4 inequalities will turn into variations. So we had 4 variations. So we have 8 inequalities. So if you look at these questions, you can see the idea, the methods of treating them are very much similar. So that's what I want to show you. Okay, what I show you. And all of these ideas is that we have something, and that something compare with 0. Something compare with 0. Then you say, why we always compare with 0? Why we compare with 0, right? Remember when we turn from x squared plus 2x larger than 3, and we turn that into minus 3 greater than 0, right? Why wouldn't we keep it as larger than 3? We could. Okay, we could use the same method, but comparing with 0 is just easier. Okay, above x-axis, below x-axis. Are you guys with me? So we use the methods in, the completing square and observing all these phenomena. In this case, we can also factor, okay? Because if this is true, right, then the factor form would be true. And what would be the factor form? Can you guys factor this for me? I'm sorry, I still cannot turn on the video. For some reason, Zoom refused to identify my webcam. So can you guys factor this? Come on, you guys. Have you waken up? X plus 3 times x minus 1. Perfect. Good job. Okay. X plus 3 times x minus 1. And that's larger than 0. Boom. We're almost there, right? Then you can work with the sign. So, and then you can do the sign of, you know, x plus 3. So pretty much all of these steps, right? All of these steps will be repeated for different numbers, yeah? All of these steps will be repeated for different numbers for them. Come on, let me do it, okay? So all of these steps will be repeated, right? So I'm just gonna quickly browse this because I want you guys to make a connection, to think that we went through. And now I want you to look at the sixth principle again. Could you guys look at the sixth principle one more time? I bet you're gonna look at them in a slightly different light. Are you looking at the principles again? 6 principles, one more time, one more look. Yes? And of course, the solution for this one, because we want it to be larger than 0, okay, that's gonna be x less than -3 or x larger than 1. Okay, so that's the completion of, you know, one of the inequalities in quadratic 4. We're not going to do all of them, okay? You guys should try all of them to reflecting on these methods, to reflect on these methods. So now, are you guys looking at the principles again? Please read the 6 principles again. Are you looking at them? So what is the first principle? Anything times 1 stay the same. Okay, the second principle, anything added 0 stay the same. Did we use that principle? We did, right? We did it. We did it in completing a square. Number 3 and number 4. Number 3 and number 4. If A is the same as B, then A plus C is the same as B plus C. If A is the same as B, number 4, A times C is the same as B times C if C is not 0, right? 5 and 6. 5, if A times B is 0, then A is 0 or B is 0, vice versa. Okay, that if and only if, right? Number 6, the sign. A times B, you know, positive times negative is negative, negative times positive is negative, negative times negative is positive, positive times positive is positive. Dividing is also true. A divided by B, if A is positive, B is positive, positive divided by positive is positive, and so on and so forth. So if you look at these 6 principles one more time with the understanding of function, input, output, everything should look a little bit simpler. Is it? Are we getting there? Yeah, I hope so. We're getting there. Right? We're getting there. Now, we're back to revisit basic 10, basic 10A. Okay, so we did a quadratic 4, we did a 1 basic 10A, and then we visit quadratic 4, and now we're back to 10A. Now, the idea that we have learned in in quadratic 4, okay, these ideas, okay, so what are these ideas? Right? Some of these ideas, such as how to find Y-intercept, how to find X-intercept, right? What the input means, vertical cut. What the output given means, horizontal cut, right? These and solving inequalities, larger than 0, less than 0, greater than or equal to 0, and so on and so forth. These ideas will not change for any function. For any function. Okay, so the ideas we learned. Okay, first one, how to find Y-intercept. How many? There's only one. If it is a function, there's only one. Okay, if it's not a function, of course, it's a different story. That's how to find Y-intercept. So Y-intercept is a point, okay? This point is 0, comma, f of 0. That's Y-intercept, okay? How to find X-intercept? X-intercept may be plural. We may have more than one X-intercepts, okay? How does the X-intercept look like? Well, the Y coordinates are 0, right? So we set f of x equals 0, because the output is given 0. That's how to find X-intercepts, okay? So when we evaluate, right, such as f of something, say f of 1, okay, what does this mean? Just an example, okay? This means the horizontal line, x equals 1, okay? Because the input is 1 and the x equals to 1, crosses the curve. That's the meaning. You follow me? It may cross, it may not cross, okay? It depends on whether 1 is in the domain or not. If it is in the domain, it will cross somewhere. Now, solve for, right? Suppose we have f of x equals to a constant, okay? Say 1. I'm just taking an example. Okay, another example, these ideas. Okay, what does this mean? The geometric meaning is the horizontal line, y equals 1, crosses the curve. How many times? We don't know. It may be more than once, maybe no times, maybe it may never cross. Okay, so these are the ideas. Okay, now number 5. F of x larger than 0, etc. Okay, this includes less than 0, you know. There are other cases, right? less than 0, right? These cases say equal to 0. 3 cases, 3 basic cases. And all you have to check is check the, the curve above or below the curve, or below the x-axis. Okay, so that idea, okay, these 1, 2, 3, 4, 5 ideas we have learned in quadratic 4 applies to every function, however complicated. So this is what I meant. This is what I meant. Okay. As far as completing a square, that's not always possible, because if you have a sine x, completing a square is not possible, right? You're not going to be doing that. But in some situation, you may get into very complicated situation that having quadratic form, then that's a different matter. Function can be very complicated. But these 5 ideas are stay with us, are going to be with us, I would say forever, forever. Okay, so let's back to basic 10A. Okay, we just look at the 6 principles, 6 mathematical principles, and now we see them in a slightly different light, right? So now we see these principles, we can make a connection. So, oh, we have used that here, and we have used that over here. We have used the other one over here, right? And we actually didn't use any other principles outside the 6 principles, okay? So yesterday we did number 6. Do you think you guys can handle everything between number 1 to number 11? Number 1 through number 11, okay? All of these are your homework. You guys should do it after class, even for those questions we did in class. Do you guys follow me? We're talking about, remember we talked about this is the study method, right? You do everything the teacher have done in class all over again, if not 3 times, until you completely understand the lecture, and then you hit the homework. That's the way to study. That's just the way to study mathematics. I don't know how to study psychology yet. I cannot give you any advice about that. But I'm just telling you how you study mathematics and be successful. Okay, study the lecture first and go through the lecture over and over, ask lots of questions. Okay, and then you hit the homework. That will be more efficient. That will be more efficient. So from number 1 through number 11, do you think you can handle them? Can you handle them? How about you pick 2 questions? Pick 2 questions. Okay, pick 2 questions and try them. I'll give you 5 minutes. I'm gonna give you 5 minutes. Okay, so let's do that. Warm up. This is the springtime. Sometimes we like to sleep a little, longer in the morning. Okay, we call it sleeping in. That's okay. And it may be a little bit hard to wake up. Okay, it may be a little bit hard to wake up. So hopefully this will wake you up. Okay, will wake you up.
Did you mean 10A or 10B?
10A. 10A. 10B is, we're not doing 10B in class. If you guys want to do them, go for it, okay? In fact, I have 10 A, B, C, D. Okay, you can see this type of questions are very, very important, and the variety of questions can be asked of them. And I collected lots of questions from different sources. Okay, primarily from the different authors, textbook of different authors. I went through a lot of lots of books. But the ideas, no change. The ideas of handling them, they're all based on number 5 and number 6. Do you follow me? The ideas all derived from principle number 5 and principle number 6. No exception. No exception. They can do it in different ways. They can make the method look very different. But deep down, the ideas from principle number 5 and principle number 6. In fact, you could have invented those methods yourself. Okay. All right. Is there anyone you want me to do? So you look at them, you have no problem, right? No problem? Because today we're going to hit from number 12 to number 15 and some of the remaining questions. Okay, do you mean basic 9A? It's basic 10A. Basic 10A, what page?
47.
Basic 10A. Let me find the page number for you. It should be behind. So all this time you don't know where basic 10A is. We'll go through the pages. It should be after. Hold on, I'm looking for those pages. Okay, I'm looking for those pages. Just 1 second. Basic 10A is on page 47. Page 47. Do you have any questions from 1 through number 11? Wait. You know what, you guys? It's basic, it should be basic 9, sorry. I think I rearranged this. My bad, partially my bad, okay. Basic 10, okay, sorry, it should be basic 9, sorry. I'm sorry about that. Basic 9, page 47. Okay. In fact, I separated them. Okay, so today we're going to do basic 10. My bad, totally my bad. Okay, so this should be basic 9. Sorry about that. Basic 9, basic 9, sorry. No wonder we have some confusions here. My fault, okay. Basic 9, okay, basic 9. Okay, basic 9, actually they're all quadratic type, so I don't need to separate. I was looking at my older version. I'm sorry. My older version, I have a hard copy, so I tend to look at the hard copy. My bad. So basic 9, page 47. Okay, so how about look through all of these questions from number 1 through number 22. You can see the variations, right? Remember we did the variations for quadratic 4, right? There are all these variations. How do we handle them? How do we handle them? Yesterday we summarized these methods. We have 2 major steps. One is making 0. The other one is making product. If we use this particular method, right, we use a sign check. Making 0 and making product are 2 major steps. But making product means that we have to factor, right? Making product means factor. So making 0 obviously is easy. We can always make 0. We can always make 0. Okay? But making product, sometimes it's easy, sometimes it's not. Okay, making product is not always easy. Okay, making product is not always easy. If it is easy, of course we go for it. Sometimes it's not easy. So what do we do? Okay, so let's spend some more time in basic 9. We probably do basic 10 tomorrow. Okay, and I apologize for the messed up. And do we have a 10A? Do we have a, we have a 10B. Sorry, that's why you guys asked, right? Sorry about that. So I should have made this 10A. It's okay. Just keep it the way, it is. Okay, it's better in print and keep it the way it is. Okay, so today we'll continue to work on basic 9. Basic 9. Okay, the basic idea is, that's right, Mikhail is right. Okay, I have basic 10, and then I didn't have basic 10A. I have basic 10B. Okay, so let's keep it that way. Okay, it's basic 10A is missing in action. Okay, so never, just don't worry about it. It's totally my fault, and so please forgive me. Okay, so now let's look at basic 9. Look at these questions. Okay, I'm gonna pick one for you if you're not picking. Okay, for example, I'm gonna pick number 7 for you. Could you try number 7? Two x squared plus x greater than equals to 1. Okay, of course we understand this is an if statement. This is the if statement. Okay, we're coming from, we spend so much time on quadratic 4. Okay, this is an if statement. Okay, so if 2x squared plus x is greater than equals to 1, right? If this is true, right? Find all possible x. So what do we do? What do we do?
Get everything to one side.
That's right, making 0. Making 0. Okay, that's just one idea. But how does this idea works? This idea works very well. You actually will see the same idea works in calculus 3. Okay, when you learn Lagrange multiplier, you will see that. Okay. When I was in college taking Calc 3, and we have this method in Lagrange multiplier. At the time, I was thinking, why they make it 0? You know, why they make it 0? Why they always move everything to one side and make it 0? And in my previous experience, no professor ever mentioned that. Well, I should have studied, right? I should have studied, but I didn't study, and I didn't see that connection. Now I do. Now I do. Okay, you can see making zeros is not an idea in algebra. It is also an idea that was used in other math classes. Why? Why making 0? Because comparing to 0 is always easier, isn't it? Right? When you compare with 0, is either positive or negative. It's greater than 0 is positive, less than 0 is negative. It's much easier when you have a picture, right? You can tell, okay, it's above x-axis, that's positive, below x-axis, that's negative. Can you compare with 1? Of course you can compare with 1, right? Greater than equals to 1, you can compare with 1, but that will be above 1, above or on 1 or beneath 1. Do you guys follow me? So comparing with 0 is just so much easier. Does everybody follow me? Yeah, so making 0. I'm so glad you guys, proposed that. So if this is true, then we're gonna make that 0. Okay, 2x squared plus x minus 1 larger than or equal to 0. And then what? Then what you do from here? We have all these ideas we can use, right? We can use, this is obviously a quadratic function. We want this quadratic function to be greater than or equal to 0, right? So we can use factoring, we can use a quadratic formula, okay? The one method we did not use in our previous exercise, we didn't use the quadratic formula because I thought everybody should know quadratic formula, okay? We just didn't want to use it at the time, but now you can, or we can use factoring. The 3 methods you have learned, you might have, your teacher might have drilled you when you were in algebra classes over and over again, the 3 methods to solve quadratic equation. So what are those for? We'll use those, whatever method you use, completing a square, factoring, quadratic formula. What do you use it for? Yeah. So did you try factoring? How many of you try factoring? All right, so what you get for factoring, Cortland? (2x minus 1). I'm not going to address the methods of factoring yet. Okay, those will, if necessary, we do that later. Okay, because those are not considered in my book, not considered very difficult topics. Okay, so we're handling the harder topics first. So could you guys check if you got it right? Did you get it right? Did you check it, Cortland? Correct. Mikhail responded, yes, I think so too. So here we make 0. Okay, make 0 is such an amazing idea. Okay, and this one is make a product. Make product, i.e. it's factoring. Factoring, okay, factor. We spend about, at least I would say 1 year, okay? In our algebra classes, we probably spent about 1 year factoring. Did you remember that? Did you remember that experience? You factor in elementary algebra, you continue to factor in intermediate algebra, and you even factor in trigonometry and so on and so forth, right? So factoring for 1 year may be an understatement. All right, so then what you do? If we work with the sign, right, we will look at these 2 signs, the sign of x plus 1. Okay, and we have a number line. Where does x plus 1 change its sign?
-1.
At a -1. Wonderful. Okay. So when we pick a number from smaller than -1, what will be the sign of x plus 1?
Positive.
When we pick a number less than -1, Okay, just try a number less than -1. Pick a -2. What sign would that be?
Negative.
Negative. Okay, that would be negative. When x equals to -1, what will be the sign of x plus 1? Neutral, right? 0. When we pick numbers larger than -1, what will be the sign of x plus 1? Is my question clear?
Yeah, positive.
Positive. Right? So we go through the drill. Now let's look at 2x plus 1. Right? 2x plus 1. So we look at the sign of 2x plus 1. Where does this number change sign?
1/2.
1/2. Perfect. Perfect answer. 1/2. Okay. And what is the sign of 2x minus 1 when x assume values less than half?
Negative.
Negative. All you have to do is just choose a number less than half, right? And plug in, right? We call it test point, right? Some textbooks use this as test point. So you can pick 0 because 0 is less than half. Do you guys follow me? So 0 times 2 is 0. 0 minus 1, that's negative. So when you pick a number, well, you can pick more numbers if you want to. You want to make sure, right? Just pick a number smaller than -2 and plugging in, then you see that you get negative sign consistently. Yes. When x equals to half, what will be the sign of 2x minus 1?
0.
Neutral, right? So when we pick numbers larger than half, what will be the sign of 2x minus 1?
Positive.
Positive. Is my question clear, everybody? If my question is not clear, please make sure you ask me to repeat. Okay? All right? It's not embarrassing to ask me to repeat certain questions. Do you follow me? Because I can even write it down. I can write down the question if necessary. Okay? So now the last piece, okay, we're going to look at the sign of the product. And you know the drill, right? But you have to be able to, you have to have a narrative for it, right? We need to have a narrative for it. So we're picking numbers. Okay, so this thing I'm drawing is the number line. This is a number line. Okay, this is a number line. Okay, do you guys still understand the meaning? Just in case? You understand the number line, right? It's a number line. This number line, basically, you pick numbers from here arbitrarily, and you pick a number from here arbitrarily, pick a number from here arbitrarily. And you can pick many numbers from each interval. And you will see the sign of this product. Basically, you just plugging in. Does that make sense? So when we pick a number from smaller than -1 and plugging in here, we will be doing a negative times negative, right? And negative times negative is what?
Positive.
Right? When we pick 0, when we pick -1, -1 plugging in here, that makes 0. 0 times anything is 0. Are you guys with me? So that's the meaning. Just in case you guys, some of you forget, right? I hope that helps. When we pick numbers from here arbitrarily and plugging in the product, and we are dealing with a positive number multiply a negative number. Do you guys follow me? A positive times negative is negative. When we pick half, when we plug in half in this product, 2x minus 1 is 0. 0 times anything is 0. Therefore, this is neutral again. When we pick a number larger than half, and we're dealing with a positive times positive. Do you guys see that? Positive times positive. Positive times positive is positive. So which principle are we using? Principle number 6, isn't it? Z, principle number 6. So now, with that discussion, okay, and the tables and the chart we worked out, what will be the solution? What will be the solution to this inequality? What will be the solution to the inequality? What will be the solution to this inequality? We want the product to be larger than 0 or equal to 0. So where do we see larger than 0? Larger than 0, positive. Equal to 0 here, right? Equal to 0, so here. So all of these numbers will be the solutions, right? All of these numbers will be the solutions. How do we express the solution?
X is less than or equal to -1, or X is greater than or equal to half.
Perfect. Very good. Very good. Okay. X is less than or equal to -1, or X is larger than or equals to half. Okay. Could I express solution this way? Okay. Could I express the solution this way? Right? X is less than or equals to -1, right? So I'm going to write as X is less than or equals to -1. Okay. X is less than or equal to it. Okay. X is also greater than or equals to half. So X is greater than or equals to half. Could I write it this way? Could I write it this way?
No.
Please don't. Please don't. Please don't. I saw this mistake many, many times. I would say I see this mistake every semester. Every single semester. When this topic is covered. Every semester. Okay. And the other one, there's another one. There's another way of expressing the solution, okay? There's another way to express the solution. Let me clean this up, right? Oops. Clean this up. Another way to express the solution is this. Okay. Here, this way. Could I express the solution this way? X is less than or equals to 1, greater than or equals to half. Could I do that?
No.
No. I'm glad to hear that. So please never ever do this. Okay. I want you guys to write down these mistakes on your notebook and cross them out. If you have a slight tendency to make these mistakes, at least this will serve as a warning sign. Okay, don't just scratch them out yet. Okay. This is called learning from our mistakes. Okay, if you're not making these mistakes, well, this is someone else's mistake, and learn from someone else's mistake. Okay, these are terrible, horrible, extremely bad mistakes. Terrible mistakes. Okay. All right. So we're good, right? We're good. So shall we try number 11? Would you like to try number 11? Let's try it. Let's solve number 11. Basic 9, 11. Okay. So let me make these are okay. Terrible mistakes. Okay, is that clear? Don't make them. Don't make them. Just write it down like this because it's an or situation. It's an or situation. Okay, and of course we could solve it by quadratic formula way, and the other there are so many ways to do it. Okay. Number 11. We have a x squared greater than or equals to 2. How do we solve it? This is the place that we don't want to be, sometimes we can have some, different ways, slightly different ways algebraically to handle these inequalities, really. Okay, you don't always have to go the same way, right? You don't always have to go the same way. Anybody want to show your work? Anybody want to show your work? Anybody want to show your work? Okay, I got Pronto, right? I also get, I have Pronto here, and I have Inbox here. I have, we can do the file upload. Anybody want to show your work? You can be creative. You could. That's not the only way though.
What if you square rooted both sides?
Yep, you can do that too. There's so many ways to do it. Yes, you can make 0. That's a way. You can square root both. You can take square root on both sides, and you can use a quadratic function. You can use the quadratic curves. There are at least 3, 4, 5 ways to do it. Okay. So if this is true, right? We know this is an if statement. I don't want to, I don't want you to forget about that context, that grammar. If you take square root on both sides, greater than or equals to square root of 2, okay? And then you have absolute value of x larger than or equals to root 2. Okay, then what? And then you can refer to the method in basic 6, remember? Right? So you get the solution. The solution will be x less than or equal to root 2, or x is larger than or equal to, that's a negative, sorry, negative root 2. Do you follow me? This is one way to do it. Are there other ways? Of course. Okay, I call this method 1. Right? Let's look at method 2. Making 0. Why not? Making 0. Right? So we have subtracting 2 greater than or equals to 0. Can you factor here? Of course you can. Right? You get an x minus root 2. Oops. Right? X plus root 2. Right? You can do the sign. You can do the sign. And everything will be the same for the sign, except what? Everything will be the same for the sign, guys. Okay, I'm just doing this quickly, and you can make a reference, right? And it's just gonna be, this is gonna be root 2. Sorry. This is gonna be plus root 2. Okay, and this is gonna be root 2 minus root 2. And this is gonna be x minus root 2. And this is gonna be root 2. Okay, and this is gonna be the product. I want you guys to see some fun in this process. You guys see some fun in this process. Do you? Can someone tell me that you actually have some good time with it? Yes? Does some of you, could some of you tell me you have actually have some good time with it? No? Nobody's having a good time? No? Is that right? Really? Try to enjoy it, okay? Try to enjoy it. Yeah? You give me a smile? Good, thank you. Right? So the solution is, so this is this, what I want to show you is that if you can factor, you make a 0, you can factor, hey, principle number 5 and number 6 is at a play, right? So we're using those principles. Okay, we're using these principles. And what would be the solution? Of course, the same. The reason you want to think of different methods sometimes is for checking. Okay, so the solution to x squared greater than or equals to 2 is that. Can we come up with a method 3? Do we have another method? Yeah. After making 0, we have this function, and we call this function x squared minus 2. That's a quadratic function, right? And we can graph this quadratic function, can't we? Right? We graph this quadratic function. Yeah? Right? And then what? There are 2 points that are crossing x-axis. You want to know these 2 points, don't we? So what are those 2 points? You first find x-intercepts. Sorry, why does it come? Find x-intercepts. And here we have 2. How do we find x-intercepts?
Set the equation to 0.
That's right. Okay, and what do we get?
Plus or minus root 2.
That's right, x squared. Are you guys doing it with me and have the fun? Right? You're ahead of me. You're ahead of me. Do that. Okay, so this is x squared, taken square root. So that's square root of 2. So, and just you go through these steps that we're so familiar with, very basic, right? Review what we did in quadratic 4, right? So x equals to plus minus root 2. Okay, so what are the x-intercepts? What are the x-intercepts? Can you compose those points? One is negative root 2, comma 0, right? And the other one is positive square root of 2, comma 0, yeah? And these 2 points are going to be on the graph, well marked. Okay, 2 red dot. 2 red dot, not circles this time. Okay, so please mark them. You get a picture to show your reader. Right, so let me just make it a little bit shorter. Okay, so what are the positive? Here's the positive. Positive piece, negative piece. And these 2 points, can we mark these 2 points? Negative root 2, comma 0. And this point is a positive root 2, comma 0. Do we understand the meaning? Do we understand the meaning? Yeah?
Yes.
What is the meaning?
Same thing as before. There was x less than equal to negative square root of 2.
And then?
X greater than the square root of 2.
Are you spelling out the solution?
Well, that's the solution, no?
Yeah, that's the solution. But what is the meaning of this piece?
Oh, that everything to the left of it is what's called positive.
Positive output, right?
Yeah, and then it's called on those points it's 0, and then in between them it's what's called negative, and then outside again positive.
Very good, right? That's the meaning, right?
Yeah.
For input less than negative root 2, the output are positive. For input greater than root 2, the output are positive. For input between negative root 2 and positive root 2, exclusive negative. At negative root 2 or root 2, output is 0. Do we follow? Do you guys follow me?
Yep.
Very good, very good. You need to have this narrative in your head. Okay, you have this narrative. So when you make a 0, you have all these different routes you can go to. So what will be the solution? Solution is same, right? So you tell the reader, so you show this to your reader to try to get her to understand. Right? You try to get her to understand. Okay. So now do you see that basic basic 9 and quadratic 4, they're together. And by the way, just realized and the homework I assigned that need to be modified as well. And I apologize for the messed up. Okay, I'm so sorry. Okay, I'm so sorry. Okay, anyway, do we have other methods? Yes, we do. Yes, we do. Okay, we just don't have time to exhaust all of them. But at least for these methods, you can see, even though we approach them by different ways, but they have the same idea, and it's all about the rule, input, output, right? Yeah. So now I want you guys to look at the definition of function one more time. Please look at the definition of function. Can someone type the definition of function on the chat? We can have multiple. We can have multiple. Go ahead. Go for it. Type the definition of a function on chat. Yeah. Come on, guys. I hope this definition is running in your blood. Okay, I hope this definition is running in your blood. So as we are on our way to get our vaccine shots, right? We might drop we might have to drop 1 or 2 drops of blood, okay, just in case. And I want you to check if these definitions and these principles are running in your drops of blood. They should be running there. They should be running there. They're running in your vein. Okay. Here it comes. Okay. Thank you, Bailey. A function is a rule. Okay, finish. A function is a rule. No problem. Take your time. Okay. Study mathematics is about taking our time. It cannot be done by very fast, you know. Math function is a rule that assign to each element x in the set of A exactly one element called f of x in the set of B. What do you think? Okay, so I'm going to copy his. That way I don't have to write it down, right? A function is a rule that assign each element. It's a rule. Okay, so he retyped it. I really appreciate your, you're being very careful writing down. Okay, type this. A function is a rule that assigns to each element x in a set of A exactly one element we call f of x in the set of B. So now as we read this definition and we thought about what we have done, right? Think about what we have done. We have been doing functions all day long, yes? We're just observing the different aspect, right? Sometimes input is given, we're looking for output. Sometimes output is given, we're looking for input. And sometimes it's just a statement, sometimes it's an if statement, yes? That's all we're doing. Do you agree with me? We're just dealing with different rules. Okay, so table basic 1 give us all these different rules. Okay, guess what? At the entry of your calculus class, calculus 1, okay, they started with function. So it will include all of these things we have learned so far, different aspect with it. And they go from there. They go from there. Okay. So all these prep classes before calculus class is about one word only, function. Okay. Just to prepare for the entry in calculus classes. All right, so with that said and done, let's go back to page 47. Okay, page 47. I'm going to choose another question for you. Okay, basic 9. Basic 9. Okay, this time I'm choosing the question number 12. Number 12. Number 12, please. Solve for x. And we have a 2x squared, I'm sorry, x squared plus 2x plus 3. And we wish it to be greater than or equal to 0. I'm going to give you a couple minutes. To solve it. Yeah? Are you ready? Go for it. So how's it going? What have we found? All right, what have you found? If you need more time, that's okay. Take your time. Shall we have some discussions now?
I don't know if I was doing this right, but I started doing the quadratic formula, and the number inside the radical is negative.
So you did a quadratic formula to find what?
I stopped at it was a fraction, and on top was -2 plus or minus radical -8, and then the denominator it was 2.
And what happened to the numerator? What happened to the underneath the square root?
Would it become? It would become like 2√2i, right, or something like that.
Okay, so you mentioned using quadratic formula. Okay. What prompts you to use a quadratic formula?
I'm not the best at factoring, so I just decided to try quadratic formula this time.
Okay. Did anybody try to factor? Well, I don't know if you try to factor. Factoring is not that easy. But I'm not saying it cannot be factored. It can be factored, but it's just not being very easy. Okay. You can see this question just a little bit different from the question we did in quadratic 4, right? And it's hard to factor. It's hard to factor. And Andy says complete a square. Very good. I'm so glad I see these varieties of different. I tried completing a square as well. That's wonderful. Okay, so let's address each one of these issues one at a time. Cortland says, is that Cortland? He was using quadratic formula. So when you use a quadratic formula, what do you think you use a quadratic formula for? Okay, we'll come to completing a square. Okay, we'll come to completing a square. Cortland, you're using quadratic formula. What is that? What do you think you get for quadratic formula?
That was,
Okay.
that was me.
Did you say something? Did you say something?
Yeah, that was me. That wasn't Cortland.
Okay, so we're gonna have a discussion here. Okay, we're having a discussion here. So when you use quadratic formula, what do you think you use quadratic form? What does a quadratic formula give you? Okay, Cortland says the x-intercepts. Perfect answer. Yes. Quadratic formula is to solve quadratic equation. Okay, so quadratic equation. Okay, so let me clarify a few terminology for everybody. Okay, so f of x as a quadratic function. Okay, which we have seen this, right? This is a quadratic function. Okay, I want to get these terminology right. This is called a quadratic function. Okay, write down quadratic function. Quadratic function, as we understand, is a rule. A function is a rule. Just tell you what is the rule of the function. Quadratic equation. Quadratic equation actually is an if statement. It's an if statement. So they are very different. But unfortunately, I saw this being confused even by some of the textbooks. Okay, and I'm not going to bother to go back there to make those changes because that's too late. So you probably have seen these used interchangeably, but I want to clarify this because I want to clarify and show you the simplicity. I want to show you the simplicity because there's only two kinds of sentences in mathematics. One is a statement, one is an if statement. That's all. So quadratic equation is an if statement. So what is a quadratic equation? If f of x equals 0, that's called a quadratic equation. Do you guys follow me? And now we understand. I'm so glad, and Cortland mentioned this, is that when do we set f of x equals 0? When we're trying, that's setting y equals 0, right? That's when we're trying to find x-intercepts. So quadratic equation give us the x-intercepts. Okay, so that quadratic formula, okay, that quadratic formula. But now the question is, does it always give us the, x-intercepts? Plus minus b, minus b plus minus b squared minus 4ac. Okay, I'm going to make the font just a little bit larger. Okay, 2a. Sorry, 2a. 2a. Okay. This quadratic formula actually does not always give us the x-intercepts. What happens? Depending on b squared minus 4ac, depending on b squared minus 4ac, okay? Depending on b squared minus 4ac, if b squared minus 4ac is greater than 0 or larger than 0, right, or equal to 0, yes, we will get 2 x-intercepts. Okay, so we get when this is larger than 0, okay, we have 2 x-intercepts, two real solutions, 2 real number solutions. You guys probably have learned this, right? 2 real number solutions. 2 real number solutions. These 2 real number solutions are the 2 x-intercepts. Okay, x sub 1, that's a real number. Okay, x sub 2, that's another x-intercepts. So 2 real number solutions. What if this b squared minus 4 equals c is 0? So if this guy is 0, the entire square root is 0. So you plus minus 0. So this entire piece is gone. So you only have one real number solution. You only have one real number solution. As a result, you have only one x-intercept. Okay, so this is mean two x-intercept. And this is just one x-intercept. And then you say, well, the last case, you know it, right? What is the last case? The last case, sorry. The last case is that b squared minus 4ac is less than 0. This is the case that you have a negative number underneath the square root. And we know that will lead us to complex number. So in this case, instead of having two real number solution, we have two complex number solution. And we know that complex numbers find no place in the rectangular system we know of. So this is the case that we have no x-intercept. Okay, so when you work with a quadratic formula, right? When you work with that quadratic formula, what happens? You have three cases. And now with this particular function here, right? We have a equals to 1, b equals what? B equals to 2, c equals 3.
3.
Right? Before I use a quadratic formula, I would look at b squared minus 4ac. And that's going to be 2 squared minus 4 times a. A is 1, b is 2. What do I end up with? I end up with a negative. So this quadratic function, well, this equation has no real number solutions, right? Has no real number solutions. There are no real number solutions. What does that tell? The curve and x-axis never touch. Okay, no real number solutions. That means that there's no x-intercept. And this parabola opens up, doesn't it? Because a is positive. So now can you picture in your mind, before you grab that graphing calculator, can you picture that parabola that opens up but doesn't touch x-axis? Can you picture that parabola? What is it? Can you picture this function? And this is a parabola that's above x-axis. Okay, so now if we graphed it, which is just a click away, right? It's just a click away. Let me just make some adjustment to this. Okay, you can see that this parabola is above x-axis. No touch, no touch, no touch. You have vertex and everything and all, but you don't have x-intercept. But just remember, what is the goal of solving for x? We just want to find all the inputs such that the function is greater than or equal to 0. Now, because there's no touch, equal to 0 is impossible, right? Because there's no touch. So we only left with greater than or equal to 0. So if if we want this to be greater than or equal to 0, what will be the solution? What is the solution? Isn't that all real numbers? Isn't that all real numbers? No, it's not no solution. Every real number is a solution. Do you follow me? Because every output is positive. Every output is positive. Remember the meaning of output? We want a positive output. All of these output, these vertical bars, they are all positive. They're all above x-axis. Do you guys follow me? We always go back to the fundamental meaning, don't we? We always go back to the fundamental meaning. Yes? Now, with all of these discussions, we have a, I'm gonna do the summary tomorrow, okay? But I'm gonna touch the, I'm gonna touch base with the idea of completing a square. I think that was a great idea. Okay, you guys mentioned this. So we're gonna continue the discussion. Tomorrow, I'm gonna do the summary, and I want you guys to try to summarize this as well. Okay, so how about this completing a square idea? Okay, so you guys tried completing a square. I think that's a great idea as well. Okay, complete a square. So what do we have here? What we have here is if you complete a square, what you get? If you split the 3 with 1 plus 2, right? Or you can plus 1 minus 1, whatever you do. You have x plus 1 squared plus 2. This guy is a perfect square. Do you guys see that? This guy is a perfect square. So x plus 1, this guy is a perfect square. So it's always greater than or equal to 0 for what? For any real numbers. For any real number x. And this sum is larger than or equals to 2. As a result, for any real number x. So this guy is the same as that. So this guy is always greater than or equals to 2. And we want it to be greater than or equal to 0. In other words, this is wanted. Right? This is wanted. And this is always true. So what is the solution? All real numbers. Okay, this is true. And this is wanted. What's wanted is guaranteed by truth. Do you follow me?
Yes.
Therefore, the solution is all real numbers. So if you do completing a square, you could go this route. Of course, you can go all these other routes, because from these examples, I want to show you guys that we can be so flexible. Okay, we can be flexible, we can be creative, and yet still comply with the principles. To be as flexible as you want to be, okay? Just like you know, suppose you are in the basketball court, you want to be shooting the basket every time you get it, or 99% of the time you get it. What is the key to that? Practice. Reflective. Reflect what you do and practice as much as you can. Okay, so tomorrow I'm going to summarize this. Okay, but I want you to give a try first. I want you to look through these examples, you know, maybe go through the lecture one more time. I think I have given some valuable feedback about these topics from my personal experience, from my personal studies. If you find this helpful, I want you to put in your own thoughts, your own reflections in this process so that this knowledge will be yours. Okay, so tomorrow we'll be continuing on this, and I should not make my plan too ambitious. Okay, so if we can cover all of these thoroughly tomorrow, finish basic 9, that would be great. But if we finish ahead of time, we will be heading for basic 10. Okay, but there's no rush because it's very, very important that we understand quadratic thoroughly, right? I have in the module, I have a title called Everything Quadratic. Did I cover everything quadratic? Pretty much, the basic ones. The basics, I think I covered everything quadratic. There's a lot of rooms that from that basic, we become more creative, right? And we, you know, we use a lot of our algebraic skills. So today I'm demonstrating to you that all these different algebraic skills you can use, right? You can actually be very flexible. You don't have to follow certain steps. You just need to let your thoughts, your logical thoughts to take its course, You have an idea, give it a try. Have another idea, give it a try. You never know where it's going to take you, but oftentimes you will be pleasantly surprised. Or if it didn't go through, you know that way doesn't work, right? So I hope I hope I can help you to enjoy this experience, okay? All right, but anyway, without further ado, I'm going to let you go. And thank you very much. And I'm going to see you guys tomorrow.
Thank you.
Thank you.
Have a good one.
Thank you very much. Very good participation, you guys. And I really appreciate that. I personally enjoy that.